Let's find the partial fraction decomposition of this rational expression. Notice that the denominator is in factored form. That will give us the number of fractions that we need. We have a over x plus 1 plus b over x plus 3. And since x plus 3 is squared in the original denominator, we'll need a third fraction, c over x plus 3 squared. Next, we multiply both sides of the equation by the LCD. The LCD will always be the factored version of the denominator that we start with. So we need to do that on both sides of the equation. Notice that when you multiply by the LCD on the left, the denominator just goes away, leaving us with x minus 19. And then on the right side of the equal sign, we need to do some distributing. LCD times the first fraction. Notice that when we do that, the x plus 1 goes away, leaving us with a times x plus 3 squared. Then the LCD times the second fraction. When we do that, one of the x plus 3's goes away, leaving us with b times x plus 1 times x plus 3. And when we multiply the LCD by the third fraction, x plus 3 squared goes away, leaving us with c times x plus 1. From here, we'll go through and distribute a little bit to clean up those parentheses. We have a times x squared plus 6x plus 9 plus b times x squared plus 4x plus 3. And then the c part we'll just leave as it is for now. At this point, we could jump straight to the system of equations, but I'm going to show you every single step. Again, it gets a little tedious, but I want you to see where everything's coming from. The left side we'll leave as it is. Now we'll go through and distribute the a, the b, and the c to remove the parentheses. Next, we're just going to move around some terms. We're going to group x squared's terms together, x terms together, and constants together. Ax squared plus bx squared. We don't have any cx squareds, so we'll move on to the x's. 6ax plus 4bx plus cx, and then the constants. 9a plus 3b plus c. Next, we'll factor out the x's. So for the x squared term, we have a plus b. We'll factor x squared out on the right. And for the x terms, 6a plus 4b plus c. Factor x out on the right, and then the constants will just copy. Next, we'll set up the system of equations. We need coefficients on x squared. On the right, the coefficients on x squared are a plus b. We'll set that equal to the coefficients of x squared on the left side. We don't see anything. Think of that as 0x squared, so that's just 0. Then we'll do the same thing with the coefficients on x. On the right side, we have 6a plus 4b plus c. Set that equal to the coefficient of x that's on the left, which is 1. And then the constants. On the right side, we have 9a plus 3b plus c equals the constant on the left is negative 19. This is a system of linear equations. We can then put this into a matrix. 1, 1, 0, 0, 6, 4, 1, 1, 9, 3, 1, negative 19. We're going to throw this into the calculator and reduce the matrix. To get to the matrix, we hit second matrix, go right to edit, hit enter. This is a 3 by 4, so 3 enter, 4 enter. Then we'll type in the entries. 1 enter, 1 enter, and so on. Always double check to make sure there are no typos. After that, we'll exit the matrix, hit second quit, and now we need to tell the calculator to reduce the matrix. Second matrix, go right to math, and scroll until we see RREF. Hit enter, and now we need to put the matrix in the RREF function. Second matrix, hit enter, and if we want, you can close the parenthesis and enter. And notice it will give us a reduced matrix. We have negative 5, 5, and 11. Recognize that column on the right side of that matrix are your values for A, B, and C. Now for the answer, we'll copy the original rational expression. And this is now equal to A, which we found to be negative 5, over x plus 1, plus B, which we found to be 5, over x plus 3, plus C, which is 11, over x plus 3 squared. As I mentioned earlier, at this point, we could have technically jumped straight to this system of equations without doing these intermediate steps if you can look ahead and see what's going to happen. If we know we're looking for coefficients on x squared, we can see that A will be there on x squared and B will be there on x squared. A plus B equals 0 because there's no x squared over here. Then looking ahead for the x terms, notice if we distributed this A, we would get 6x or 6a down here. Same thing with the B. We have 4b because it's beside the x, and then cx, or just c in the system. Then for the constants, we would have 9a, 3b, and 1c. So if you can see ahead, we can skip some of these intermediate steps to jump straight to the system.